Kia ora Year 12 and welcome to a lesson on the Building Problem 2 practice assessment. So this is quite a long piece of work, so just follow along as you can. Hopefully you've had a go at this already. If you've struggled with Building Problem 1 and Garden Problem, then hopefully you can use this to see my approach to one of these questions to help you tackle the next problem, the Building Problem 3 question. Okay, so let's have a look at the specifics of this question. So, the waffle at the start says Tim is designing a building for a customer. He's come up with a creative design for the building layout, which involves 3 triangular rooms, one of which has a sector removed from it of radius 30 meters. Actually, it's 2 of the rooms have a sector removed from it. That's a mistake in the waffle. The specifications for a building layout are labelled on the diagram below. So, not much useful information there other than the radius 30 meters. Again, that was a mistake on the sheet. I think it says 10 meters. Actually, on the sheet it should be 30 meters. But you can tell that from the diagram below, because the diagram below is actually labelled correctly. So, what do we actually want to do here? So, there's 3 bullet points. First one is, what is the floor area of this building? Okay, so that is working out the area of each of these 3 triangles and the area of a sector and putting together a composite shape where you add the 3 triangles together and take away the area of a sector. The second bullet point is the builders realise that they need to increase the size of a building. They decide to do this by changing the size of a sector. They wish to add an extra 200 meters squared, calculate the new radius of a sector. So this part here is a constraint on the sector and how you can change it to affect the total area of the building. And the last bullet point is, what is the perimeter of the building? So that's just calculating how far around the building goes, and that is for the original building, not the modified building, although it's not very clear in the question that's been provided. So let's have a look at how we'll do this. So the 3 triangles that we got here have various amounts of information on them. Okay, remember, to do any other trigonometry you always need at least 3 pieces of information. So the triangle ABC has 3 pieces of information. It's got 2 sides and an angle between. The triangle ABD, okay, has only 2 pieces of information. It's got a side length there and an angle, but the other 2 sides are missing and there's no other angle information. And the triangle ADE again only has 2 pieces of information. It's got a side length and an angle. Okay, so I'm going to start with the ABC triangle, because that is the only one I can actually work on currently with the information that has been provided. So I want to find the area of a triangle, because I need to find the area of a total shape, and I also want to find the length of AB, as that will allow me to get some more information for triangle ABD, so that I can then work out the size of triangle ABD and use that information to help me with AED. Okay, so let's do area of ABC first. Let's change it to a better sized thickness. So area of ABC. So that's using the area of a triangle formula, which is a half AB sine C, where you say that the angle between the 2 sides is C, which it already is, but C, and there's 2 sides next to the angle at A and B, so A and B. So for my area of ABC is half times 51 times 73 times sine 104. So 0.5 times 51 times 73 times sine 104 on a calculator gives me an area of 1000 806.2 meters squared. Okay, so I've got one of my areas. I've shown one skill towards solving the problem so far. The next thing I need to find out is the length of this side here. Okay, so the length of BC. Okay, so I've got two sides and an angle between it, and I want to find out a third side. So it's three sides, one angle. That must mean I'm using the cosine rule. So cosine rule for side length is written as c squared equals a squared plus b squared minus 2ab cos c. And you get given all of these formulas in the assessment, so you don't need to memorize them, but you do need to know how to use them. So in the cosine formula, the unknown side is c, and the angle opposite the unknown side is capital C, which it already is, so I don't need to change any of my labellings currently, because they already match up with what I currently have on my diagram. So I want to know c, so c squared is equal to my a squared, which is 51, plus my b squared, which is 73, minus 2 lots of my 51 and my 73 times cos of my angle 104. Okay, because I want c and not c squared, I need to square root all of this. So square root 51 squared plus 73 squared minus 2 lots of 51 times 73 times cos 104. So I'm just going to quickly type this into my calculator. Square root 51 squared plus 73 squared minus 2 lots of 51 73 cos 104 gives me a side length of 98.6 meters. So 98.6 meters. So here is now 98.6 meters. Okay. If I had done this in the assessment and I'd done it all correctly, then at the moment I am actually looking at an achieved, because I've shown two skills towards answering the question correctly. So that would be achieved. The two skills have to be two different ones. So that's sine rule, cosine rule are different. Area of triangle and arc length or arc sector area. So any of those skills are different and they will allow you to get achieved. So 2 of those 5. Okay. So I've shown 2 of 5 skills, so I've got achieved. For merit, I need to actually find the actual area of this shape. Okay. So let's just slide on to another one, because I don't want to make this too messy. So the information that we've just gathered is that this side length here is 98.6 meters. Okay, so we've done triangle ABC, we found its area, we found the information that we need for our next triangle. So let's have a look at ABD. So ABD, I'm just going to draw a little quick side sketch of ABD because it's got the sector removed from it, and when I'm talking about ABD, I'm talking about the full triangle ABD without the sector removed. So the side length here is 98.6. The side length at BD will be the two lengths added together, so that's 65 meters. And the angle ABD is 85 degrees. Okay, so I want to find the area of this triangle here. So let's label up the diagram. Sorry, I want to find the area, so I need 2 sides and the angle between. I've already got 2 sides and the angle between. I've got these 2 sides and I've got the angle between. So I'm going to label this up so that I can find its area. So you call the angle C, and you call the 2 sides A and B, either way around you want to do it. Okay, and then you use the formula half AB sine C, so half times 65 times 98.6 times sine 85 will give me the area of ABD. Okay, type it into a calculator. Gives you an area of 3,192.3 meters squared. Okay, so that is the area of ABD. Okay, so I've got two of my areas so far. I've got area ABC and ABD. I now need AED. Again, there's only two pieces of information. I'm missing a side length AD. Luckily, on my triangle ABD, I've got the side length AD. So using triangle ABD, I'm going to find the length of AD, so I can look at ADE. So again, I've got two sides on the angle between, and I want to find the length of the side opposite. So I'm still going to be using cosine rule here. Three sides, one angle, cosine rule. So cosine rule is c squared equals a squared plus b squared minus 2ab cos c. So a squared plus b squared minus 2 lots of a, b, cos c. Okay. To get c, you need to square root all of that above line. Okay. So c is the square root of 65 squared plus 98.6 squared minus 2 times 65 times 98.6 times cos 85. Do it on your calculator. You're going to get the length for AD as 113.3 meters. Okay, so that is length AD, and that is 113.3 meters. So when doing this, please make sure that you are communicating what you're working out each time. So writing area of ABD and length AD, so that when reading it, it is clear what you are trying to do, so that it's clear why you are trying to do it. Okay, length of AD also continues down into that sector area, so make sure that you are including that when it comes to ADE. So let's have a look at ADE now. So we've just worked out that length AD is 113.3 meters. Okay, again, the triangle we've got here is got a little sector moved out, so I'm just going to draw a quick sketch of it to one side. So we've got A, we got D, we got E, we got 113.3 meters, we got 90 meters, because this 90 actually extends into, so look at the arrows tell you that 90 is actually the whole thing, not 90 plus 30. Okay, and the angle at the top here is 88 degrees, and we want to find the area of this triangle. To find the area, we need two sides and the angle between it. Okay, at the moment we've got two sides, but we don't have the angle between, or we've got one side and one angle, and needing of another side to find its area. I would recommend finding AE rather than trying to find the angle ADE, as AE will actually help us in our final problem, which is the perimeter of this shape. However, at the moment we've got two sides and an angle, and we can't use the cosine rule because we don't have the angle between these two sides, so we can't find AE. Okay, because you need two sides and an angle between to find a third side. So we are going to have to use the sine rule here. So in terms of my diagram, I've got a side opposite an angle, and I've got another side opposite another angle, but we don't know this angle just yet. So we're going to work out that angle there. So I like to label my unknown angle A, which fortuitously it already is labelled A. So this is A. Side opposite is lowercase a. My other two side done angles are B and B. Okay. Because I'm trying to find the angle, I want to use the sine rule where the angle is on top. So that is sine A over A equals sine B over B. So this is for angle DAE. Okay. So sine A, because I don't know it, over my side A, 90, is equal to sine of my other angle B over my other side, which is 113.3. Now it's just rearranging this to find the angle by itself. So sine A is sine 88 over 90, sorry, sine 88 over 113.3 times 90, and then A by itself is the inverse sine of the above line. Okay. Quickly on the calculator, so shift sin sine 88 over 113.3 times by 90 is 52.5 degrees. Okay. So the angle there is 52.5 degrees. I can now use that angle that I've just calculated to find the angle at the bottom here, which is going to be 180 minus the two other angles. So 180 minus 88 minus 52.5 is 39.5 degrees. That will allow me to find the area of this triangle, and it will also allow me to find the length of AE by using the cosine rule, or I could use the sine rule with angle opposite side, angle opposite side. Sorry, angle opposite side and another angle opposite side, with either one of those two. But I'll save that for later. So for now, I'm just going to find the area of ADE. So area of ADE, which is going to be a half times, and here I am going to, oh, I don't actually need to, so I've already got A and B as my two sides. This is now C, which is my angle 39.5. Okay, so half times 113 point, sorry, well, doesn't really matter, but half times 90 times 113.3 times sine 39.5 gives me the area of ADE as 0.5 times 90 times 113.3 times sine 39.5 is 3,243.0 meters squared. Okay, so I've got the three triangles now. I've got the area of the three triangles. I now just need to find the area of a sector so that I can find the overall area of a shape. At the moment, my sector is missing some information. I've got the radius of a sector, and I've got one of the angles in the sector, but I need the other angle here so that I can find the total angle of a sector, so I can find its area, and that is the angle BDA. So that's part of this triangle here, BDA. So I'm going to go to another page to work out the angle BDA, and then use the combined angles to find the area of a sector at D. So the side lengths I've got are 98.6 and 113.3. So 98.6 and 113.3. And I know the angle there is 39.5 degrees. 39.5 degrees. So I'm trying to find the angle here, this unknown angle here. So a quick sketch of the triangle that I'm looking at. I'm looking at this angle. I've got 98.6 here. I've got 113.3 here. I've got 85 degrees, and I've got 65 meters along here. So because I've got two angles and multiple sides, I can use the sine rule for angle logem. So side opposite angle, side opposite an angle, and that will allow me to use sine rule to find the angle there. So let's call my unknown angle A, side opposite A, other angle B, side opposite B. So I'm going to be using sine A over A equals sine B over B again. So that is sine A, and I'm looking at, angle ADB. So sine A over 98.6 is equal to sine 85 over 113.3. Rearrange, sine A equals sine 85 over 113.3 times 98.6. So A is the inverse sine of the above line. So A is equal to inverse sine 85 over 113.3 times by 98.6, close bracket, and that is 60.1 degrees. 60.1 degrees. So now I have my sector. So the sector, that's a bit of a rubbish sector. There we go. I've got a complete angle. Damn, rubbish sector. Doesn't even look anything like the diagram. There we go. So I've got a full angle here of 60.1 plus 39.5, which is 99.6 degrees. And I've got a radius 30 meters. So the area of the sector is theta over 360 times pi squared, which in this case is 99.6 over 360 times pi times 30 squared, which gives me an area of a sector, 99.6 over 360 times pi times 30 squared of 782.3 meters squared. Okay. Now all I need to do is combine these four values together to get an overall area. So this is 782.3 meters squared. We've got 3243.0, 3243. We've got 3192.3, 3192.3, and we've got 1806.2. 1806.2. Okay. So the three triangles are added together with the sector taken away. So total area is going to equal 1806.2 plus 3192.3 plus 3243.0 plus minus 782.3. So the total area 1806.2 plus 3192.3 plus 3243 plus, minus, keep doing that, 782.3 is 7459.2. 7459.2 meters squared, plus or minus a couple of decimal places depending on the accuracy of your rounding. And that would be equivalent to a merit level answer. Okay. For the excellence level, you need to go back to the next couple of bullet points, which is the builders realise that they need to increase the size of the building. They decide to do this by changing the size of a sector, and they want to increase the size of a building by 200 meters squared. And lastly, the perimeter of a building, which you've got most of the information for, because you've got the sides. You're just missing the arc length and that side, and then you can pretty much just add everything up. It's quite a simple one at the end. So let's have a look at changing the area by 200 meters squared. So if I want to increase the area of this shape by 200 by changing the area of a sector, because I'm taking the sector away, what I actually need to do is decrease the area of a sector, because I need to decrease what I'm taking away to increase the area that I have. So I want to decrease the area of a sector to 582.3 meters squared. Okay, by changing the radius here. Okay, so to do that, I'm going to look at another page again. So I want this to be 582.3 meters squared, and I don't know R currently. So this is the information I've got. The area of a sector is theta over 360 times pi r squared. That gives you the area. Okay, so I do know my theta. My theta is 99.6. Okay, so 99.6 over 360 times pi. I don't know my radius, it is just r at the moment, and my area is now 582.3 meters squared. Okay, so all it is a rearrangement of this to calculate r. So I'm going to get rid of a meter squared because it's going to get in the way of my rearrangement, and I don't want it to be confused as some algebra. So the first thing I would do is times up by 360 and divide by 99.6 to get pi r squared by itself. So pi r squared is 582.3 times 360 over 99.6. So I've times up by 360, divided through by 99.6. Then r squared is all of this divided by pi, 582.3 times 360 over 99.6, all divided by pi. And I know this is bad maths, I shouldn't really be writing like this, but in terms of the actual calculation, your calculator will handle it, and it's nothing really to worry about. I should have really done the fraction over everything, and then it should be 99.6 pi on the bottom, but because this isn't about a task about rearranging formulae, it's about actually finding an answer, then it doesn't really matter. Okay? And then to get r by itself, I need to just do the square root of all of that. So 582.3 times 360 over 99.6, all divided by pi. Okay? So that gives me an r. Square root fraction. Oh, yeah, square root fraction 582.3 times fraction 360 over 99.6 divided by pi. Ooh, what have I done? Wait. Divided by pi is 25.9 meters. So that's the new radius. And I should communicate that with writing. So the new radius of the sector to increase the size of the building by 200 meters squared is 25.9 meters. Okay? And I probably should have done a little writing here, being the total area of a building is this, but I didn't. Okay? Last thing is the perimeter of a building. So these are the two extra constraints for excellence. The perimeter of a building. So for the perimeter, I need the length of AE, and I need the arc length here. Other than that, I've got the length here at 35, this length here at 51, this length here at 73, and this length here at 90 minus 30, which is 60 meters. Okay, so arc length and AE. So AE is back from the triangle ADE, which is here. Okay, so as I said earlier, there was two ways of doing it. Either I can use the cosine rule with these two sides and this angle, or I can use a sine rule. I personally prefer the cosine rule, so I'm going to use the cosine rule using the two sides and the angle between. So that is 113.3 and 39.5. So let's get a pen out. So I'm looking at ADE. That's 113.3, that's 90, and that was 39.5, was it? Yeah, 39.5. Okay, 39.5. Okay, so I've got two sides and the angle between. I want to find the unknown side opposite. So three sides and an angle, cosine rule. The unknown side is C, the angle is C, the other two sides are A and B. So cosine rule, c squared equals a squared plus b squared minus 2ab. I'm running out of room there, I'm going to just write this again somewhere. So c squared equals a squared plus b squared minus 2a b cos c. To find c, square root all of that. So c is the square root of 90 squared plus 113.3 squared minus 2 lots of 90, 113.3 cos 39.5, close brackets, 72.1 meters. 72.1 meters. Okay. The last thing I need to do then to find the perimeter of this is the arc length. So I know the angle there is 99.6 degrees from previous calculations. Let me just properly label my stuff. So length A. So arc length is theta over 360 times 2 pi r. Okay, I've got my angle theta 99.6. My radius is 30 because it's back to the original question. So 99.6 over 360 times 2 pi times 30 gives me an arc length of 52.2 meters. So 52.2 meters. Okay, so last job to find the perimeter is to add it all up. So the perimeter is going to be 51 plus 73 plus 72.1 plus 60 plus 52.2 plus 35, which is equal to 1 plus 73 plus 72.1 plus 60 plus 52.2 plus 35 is 343.3 meters. 343.3 meters. Okay, so that is the entirety of this piece of work. Like I said, it is a long one because it does mirror what an actual assessment would look like, which you normally have 50-55 minutes to do, and obviously it's taking a bit longer because I've had to talk throughout and explain each step. But that's everything. Hopefully I haven't made any mistakes. It's very possible that I have, because it is a long piece of work and I could have easily messed up a number here or there transferring it from page to page. If I have, just let me know and I'll send out corrections to this. But other than that, hopefully you understood it. Hopefully you can tackle the next problem tomorrow, and I'll speak to you again soon. Bye.